The last topic that we want to cover in this section is identifying the shape of a histogram. So if we have a bunch of data, we create the histogram, whatever our bin width should be, and then talk about just the general shape of that image that we see. In this first case, we have data that we refer to as approximately symmetric. In this case, this graph is perfectly symmetric, but it's very rare that with real data we see something that's actually completely symmetric. So what we're looking for is something that's at least approximately symmetric, meaning if we draw a line of symmetry on that tallest bar in the center of the distribution, it should look more or less like a mirror image on each side. Whether or not our data is symmetric is going to inform choices about things that we can do with our data later on, and we'll eventually get to that. For right now, this is sort of we're just talking about this idea in isolation, but it's going to help inform some decisions later on. We can also have data that's left skewed. This is an extreme example of left skew, but what we see is we have a center of our data, and then everything kind of tails off to the left in a decreasing fashion, and we don't see that same behavior mirrored on the right-hand side. Similarly, we can have a right-skewed distribution, where we see all of our data tailing off and those frequencies decreasing off to the right, without that same behavior being mirrored on the left-hand side. Those are the three types of distributions that we'll really focus on, but just to generally be aware of, we have some other types that can occur. Not everything is symmetric or one of those types of skew. We also have what we refer to as a uniform distribution. So in a uniform distribution, while all these bars aren't the same height, we could draw a horizontal line that roughly approximates those heights. So with some degree of difference, all of those bars, all of those frequencies are more or less the same. In a bimodal distribution, we have what looks like two approximately symmetric distributions, but part of the same graph. So if we just looked at the left-hand side of that, we see something that's approximately symmetric. The right-hand portion is approximately symmetric, but all that data considered together gives us this bimodal, these two different peaks in our distribution. That can be important because it often represents that we have two different smaller groups contained inside the larger group that we're considering. If this was something like looking at the distribution of grades in my classes, this might be something where we have a group of people who are averaging a B and a group of people who are averaging a D in the course. So two different populations, one that was more or less adequately prepared for the course, and another group that maybe wasn't as adequately prepared or wasn't provided with enough support. So it can be difficult to determine what that bimodal pattern means, but it's important to consider. We can also have a multimodal distribution, so we get more than two peaks. And then our last case would just be basically just a random distribution. So no clear, real, discernible pattern, doesn't necessarily fit with the bimodal or multimodal, not symmetric, not skewed. So those are more just for generally being aware of when you see data. It's not going to fit one of these patterns perfectly. But what we have are these three very sort of extreme examples of a right skewed, left skewed, and approximately symmetric distributions, which again, moving forward, will help inform us about types of calculations that we can use on data, and we'll get into why those are more appropriate or less appropriate given the shape of our data.